So this is titled What Owners Should Know About IPD, but I think everybody will get a little bit out of this presentation. To introduce myself, so my name is James Pease, and I'm primarily a healthcare owner's representative. I've been working either for hospitals or as an owner's representative for hospitals for the last 20 years. I went to UC San Diego and I studied management science and engineering. I did not realize that you could study construction, or I probably would have done that. And actually fell into construction management in a summer job and found it really fascinating and rewarding. While I was in college, I spent a lot of time at the beach, and I joke that I mostly majored in Excel, spent a lot of time doing spreadsheets, and a lot of my career as an owner has been in spreadsheets and now a lot of PowerPoint. And then just for fun, I also help produce some television shows. And so these webinars feel a little bit like a production. When I left school, I worked for Stanford Hospital in Palo Alto and started kind of moving furniture, repainting offices. Then I started renovating the offices and moving people in. Then I started building clinics and moving people in. Then I moved to a consulting firm and worked for Washington Hospital, John Muir Health, UCSF, and Sutter. Uh, Always doing larger and larger or more and more projects, started doing ground up buildings. And for the last 5.5 years, I've been at the University of California, San Francisco. We have currently a $7 billion healthcare program that I am leading with a number of really amazing people. We're building a children's hospital in Oakland, and we're building a major expansion to our adult hospital in San Francisco up on Mount Sutro. Be careful building a massive hospital building on the side of a mountain in the middle of a big city. It has lots of challenges. And then we're also working on our first multi-use clinic, which is a proton cancer treatment facility, primary care, and then a unique lab incubator to foster startups in the health sciences space. So between those three projects, about $7 billion worth of work. The two hospital projects are delivered with integrated project delivery, and they're the first IPD projects for the UC system. I believe some of the first public IPD projects in California. There's not a lot of public IPD projects in the US. And so our goal is to create case studies that other public entities can use to try to further the adoption for IPD for projects where it's appropriate. So a little bit about just the evolution of my career. When I started at Stanford, most of the work that we did was design, bid, build. We took the low bidder. As you can imagine, my initial projects had a lot of change orders, a lot of delays. We really didn't invest in pre-construction. Um, and when I went to Washington Hospital, similar thing. Washington Hospital is a public entity, follows the public contracting code. So the best we could do for collaboration was just to pre-qualify the bidders to make sure that we had bidders that were had done similar projects to make sure we didn't get somebody who was completely out of their element in doing a hospital project. But one of the projects I got involved in was a $5 million project with a $2.5 million claim. It was a year late, and we value engineered out the last phase of the project because we couldn't afford to do it. It was primarily due to just discovered conditions, lack of pre-construction. There was no, you couldn't model then. And so I really got a taste for how projects can go wrong, and really that the owner has so much control about how they set up the rules. I think very clearly the owners set up the rules and everybody else plays by those rules. So if for the owners out there, if you are not getting the results that you want on your projects, you probably need to change something. Continuing to do the same thing and expecting different results, I believe that some would say is the definition of insanity. So if you're not happy with the results that you're getting on your projects, it's really up to you to take a look at how are you delivering your projects? How are you assembling your teams? How are you handling incentives? And so today I want to talk about integrated project delivery. It's may not be available for every agency, and it's also I'll close at the end. I don't think it's appropriate for every project. There's no one size fits all approach. So I got exposed to integrated project delivery when I joined Sutter Health in roughly 2007. The project on the right was kind of the last big CM at risk with the GMP project that we did. And this project still finished about 6 months late and about $100 million over budget. Modeling was just starting. So all of the trades were learning how to do modeling and coordination on the project. There was some pre-construction, but once we got into construction, the generally the general contractors are, well, we got what we got and we didn't get what we didn't get, and so everything else is a change order to the owner. So a lot of change orders on the project, a lot of delays. Last planner system, at least for us, was not widely implemented, and so it was still pretty traditional 6,000-7,000 line item schedule, and we had maybe 2 months left to finish the project, and the schedule got updated, and we got pushed out 6 months in a week. So these were some of the formative experiences for me of just frustrations of having really good people on the projects, but the way the projects were structured, we were just not able to get reliable outcomes for the owner. And so what we're building is healthcare spaces. So for those that work in healthcare, you'll recognize these types of spaces. For those that don't, I think people often don't understand the complexity of healthcare spaces, much like semiconductors or biopharmaceutical construction or data centers. There's a tremendous amount of coordination. So this is a hybrid operating room, and it looks really nice and clean when it's finished, but the amount of coordination that goes into these spaces. So this is an example of what's above the ceilings in these rooms when they're under construction. There is a tremendous amount of modeling and coordination, especially in renovations in older buildings. The floor to floor heights of older hospital buildings really don't accommodate what we need to put above the ceilings now. Um, Down in this lower left, you can see this is the steel for the boom support. So especially in California, where we have earthquakes and we're regulated by the Office of State Hospital Planning and Development, OSHPD, they there's heightened scrutiny. I have often heard the only thing more regulated than hospitals in California is the nuclear industry, and maybe in Florida as well with the hurricanes. So everything that we install has to be installed per the plans. Everything that deviates from the plans needs an amended construction document. Sometimes those documents can take 1 to 3 months to work their way through the state. And they also, you're not allowed to build at risk. So you can't proceed with the change and wait for the documents to get approved. So having a building that's not coordinated and trying to do coordination and finish design and construction completely destroys your project. It causes delays. Those delays ripple throughout the building because you have lots of areas where you have to stop work. So implementing last planner system, really heavy pre-construction, focusing on modeling so that you can fabricate from the model, are basically just the key things that you have to do to get in the door to do these types of projects. So if you step back, this if you haven't seen this book, I'd highly recommend checking out How Big Things Get Done. This is a summary of a tremendous amount of data of mega projects, but I think most of the learnings in this book apply to any type of project, not just mega projects. So most general contractors that I talk to will tell me that they've never been over budget on a project. And I think from their point of view, because they got their change orders approved, they weren't over budget. But from the owner's point of view, most projects are over budget. And the bigger and more complicated the project, the more likely it is to be over budget and delivered late. And I think the most interesting part about the research is that while a good amount are delivered on budget, 27, if you can call that a good amount, most are not delivered on budget and on time. So it means a lot of them are delivered late. And then this interesting thing, the first time I've seen this studied, only 0.2% of this 3,000 sample of projects were delivered on budget, on time, and on benefits. So what that means is that when the project was originally created and the owner said their conditions of satisfaction, this is why I'm building the project and this is what I'm hoping to get out of it, in 99.8% of the time, the project may have been delivered on budget and on schedule, but something got cut out of the project. So they didn't get the full value that they intended to get. So the example I gave of one of my early projects, we quote value engineered out the last phase of the project. That means when we funded it, we thought we were going to get a PACU, a post anesthesia care recovery. So where the patients wake up and recover from anesthesia after a surgery, we didn't have the money to do that because we spent the whole project budget doing the OR renovations. So the more that we look at, not only did we finish on time and on budget, but did we get all of the things and all of the quality and all of the program that we set out to get when we put the original budget together? If we look from that lens, most of the time we're not doing that. So just going to set the stage about why you should consider IPD for projects. And so from my time at Sutter, I was involved in 25 projects that were delivered with IPD where I was the day-to-day PM on the project. There were a number of larger projects that were delivered at the same time. So why did Sutter start to look at integrated project delivery as a new way of delivering things? And so, first of all, you got to understand if you're not from California, we have earthquakes. And so, the upper left hand corner, 1973, you have the Sylmar earthquake, and the VA building collapses, kills a number of people. And then in 1994, on the right hand side, we have the Northridge earthquake, where another existing building collapsed. So out of that, California created an agency to regulate hospital construction. And then they created a set of timelines where the first thing they did is said all new buildings have to meet higher seismic standards than every other building. And then in 94, after the Northridge earthquake, they created Senate Bill 1953, we affectionately know as SB 1953, which required all existing hospitals to be brought up to new seismic standards. So in many cases, you can't retrofit an operating hospital while it's full. You can't just move the emergency department up to another floor for a year while you retrofit the columns on the lower floor. You can't just start doing surgery procedures in patient rooms or move the ORs down to the ED. So in most cases, hospitals have built a new hospital either in the parking lot or across town and then move the patients out of the older hospital. So Sutter had at the time, it would be much higher in today's dollars, roughly a $7 billion exposure for the existing hospitals that they had. And these are the first three hospitals out the gate as part of this retrofit plan. All of these hospitals were significantly late and they were significantly over budget. And so as Sutter leadership started looking at the other 5 or 6 hospitals that need to be built, if we went $1 or $2 billion over budget on that program, you start to actually jeopardize the financial viability of the organization. We couldn't afford to go that far over budget on the remaining program. And so, as I said before, if what you're doing is not working, you need to try something else. And so, from the Sutter board perspective, they were willing to try something different because, from their point of view, how could it be much worse than our existing experience? So it was we were willing to try something new. And so with integrated project delivery, this is a summary of some of the projects that were delivered. So collectively, I ran these numbers about 5 years ago when I was still working there. We had delivered 24 projects at about a $4 billion valuation. That 4 billion is really about 5 years ago. So it's probably $7 or $8 billion worth of work by today's standards. This collective program was 3% under budget, and most of these projects were delivered on their original schedule, and they did not have scope value engineered out of the project. The only project that actually finished over budget was the lower right. During the financial crisis, the exterior skin contractor went bankrupt. It was a proprietary design system permitted through OSHPD, so you couldn't easily get another trade contractor to come in and finish that work. So even with those, I think the project finished about 3 months behind schedule and $3 million over budget on a $428 million program. So, within a margin of error, while we report it did go over budget, um, the amount of over budget was nothing compared to the $300 million over budget that one of the previous buildings had been. So I put this at the front to say here are some facts and some numbers that support that integrated project delivery is a good delivery model for building hospitals. And I would say for building anything that is highly complex, and especially things that have a lot of interaction between, for example, mechanical, electrical, plumbing, fire sprinkler, framing, and drywall. If you have a complex set of systems and they're tightly integrated and they overlap with each other, like the earlier picture I showed with all the systems that need to fit above the ceilings, you need to you don't need to, but you get a much better benefit from having an aligned contract. And so I'll talk more about how you structure these deals and how they get run. But this is the lead to say this works, at least within this program. There are tangible, um, quantitative results as compared to our experience with other delivery models. So IPD is a delivery model. I would say it's more a process, an end-to-end process. It's got a lot of components to it. In the early phase, and I'll talk more about each of these, you need to align what the owner is trying to achieve. What are the conditions of satisfaction? Why does the project exist? How much money do you have to build it? And so usually for hospitals, you can say, if we have this many ORs and this many patient rooms, we can see this many patients, we can generate this amount of revenue. And that tells you how much you can afford to spend on the building. And then you can work that equation until you get to kind of the optimal program and budget that makes business sense for the organization. You put a team together very early in the project, and then you go through, I'll talk a little more about validation, but you go through a further alignment where you get the designers and the builders and the owner on board through a focused, disciplined effort to validate the project. This is usually taking it kind of through late schematic design, but some design development and construction document that's important for pricing is pulled forward. It finishes with a validation study or a validation report. And then that's typically when the final investment decision is made, when the owner commits the total funding and the team commits to deliver the project. This is usually when the full IPD contract is signed. It's often signed before validation is complete, but the actual the numbers and the scope of the job are either done after validation or they're amended into the IPD contract after a validation. This is before design is complete. So you then need to complete the design, the coordination, finite coordination, modeling, everything required to actually fabricate and assemble and build the building. And then there are a lot of tools of how you manage change and how you do financial forecasting within this model, because the financials of the major designers and builders are open book with guaranteed cost reimbursement. So tracking projected cost to complete and how you're handling contingency is more important to everybody on the team than in other delivery models where if each company has their own contract, they're essentially isolated from issues of other team members, where in this contract they have a shared risk and reward. And then all through validation, contracting, design completion, you're doing target value delivery, which is you're making sure that the design is getting completed within the budget established in the validation phase. So if I were to simplify IPD just down into three big buckets that you need to focus on, let me get my animations to work here. So I'll talk a little bit about the contract. The IPD contract is substantially different from a CM at risk or a lump sum or a design professional agreement. It's a single contract for design and construction. It has multiple signatories. So at a minimum, the owner, the lead designer, and the lead constructor. There is a single dollar value. The team puts their profit at risk. In exchange, the owner guarantees the actual cost of all of the parties and agrees to a shared savings plan. There is a commitment to collaborate and then a general waiver of claims. So all the parties agree that, except for generally gross negligence, they're not going to sue each other. And what that means in practice is all of the CYA paperwork that we have to do to figure out whose fault it is goes away, because there's no fault that you're going to sue over. So the team can just focus on what needs to be done. Now, just because you have a contract in place, I've learned the hard way, does not automatically mean that people work differently together. We all have habits and behaviors and things that we've been doing for decades. And so if you don't focus on integrating better ways of working, you can still get similar outcomes even though you have a different type of contract. So implementing what I'm calling a lean operating system, there's a whole body of knowledge that includes the last planner system, target value design, CBA, decision making, TAT planning, a lot in I don't know that it has a name, but really how to effectively manage the BIM, the coordination and VDC process, prefabrication. So all of these, I would say, are tools and philosophies that you need to bring to the project to actually get the full benefit of the shared savings and the risk reward nature. And then finally, just having good processes and an aligned contract does not make you a team. The best projects focus on culture. They focus on building a project first mentality, even going so far as that people stop introducing themselves with which company they work for. They start saying, I'm the electrical engineer for this project, or I'm the mechanical contractor for this project. So they talk about what their specific role is and how it relates to the project, not the company that they work for. So the best teams invest in culture, they focus on culture, and they build teams that, from personal experience, those early projects I talked about, I was glad to be done with those projects. I was frustrated with the people. I didn't want to work with them again. The complete opposite of that is most IPD projects I've been involved with, the team was sad when the project ended because there was such a good vibe and a good relationship among all the parties. It was so much fun to work on the project that a sadness or a letdown when the project comes to an end and the team gets broken up and people get dispersed to go separate ways and work on other projects. So in summary, for IPD to work, you need the contract, you need the lean operating system, and you need to focus on culture. So I'm going to talk a little bit about, okay, the first step after the owner figures out what they want to do is you need to actually build this team. You need to select your partners and you need to get them aligned and on the same page. This is an old graphic, but still, I think one of the best ways of describing onboarding and how it relates to validation. So the left side is a typical design bid build. I would say even CM at risk and often design build projects are still generally hiring people late. So the horizontal axis is the time of the project. So you've got the schematic design, design development, construction documents, and then into construction traveling horizontally. Vertically is the common understanding. So this means, do all of the individual people and companies that are working on the project actually understand the project? And because we typically don't bring trades on until permit documents are done and we bid the job because we're really worried that we can bid a complete scope, we wait to get trade partner impact or input into the job. And so it's not really until well into construction before the trades who are actually building the job fully understand, they've been through all the drawings, they've uncovered all of the coordination misses, the things that are missing in the drawings. So the opposite of that is a collaborative approach. So you can do this in progressive design build. You can even do it with CM at risk, but in integrated project delivery, it's incredibly important to do this early. You bring the major trades, the architect, the CMGC on board real sometimes before you even start schematic design. In the programming phase, you have these parties on board and they're advising the design team and the owner on what is the market, what do things cost, what's the most cost effective way to design a building. And you go through this very focused validation effort together. And at the end of that validation phase, you have a book, which is a clear summary of the scope, the schedule, the quality, and the budget for the project. And then the owner, the architect, the contractor, and often the major trades and engineers will sign that document and attest that they can deliver that project for that amount of money. And then you use that document throughout the project as your North Star to check back and say, are we still delivering what we said we were going to deliver? Now, often these teams, because there's nothing to bid, are hired on a qualifications basis. So you look at who the individuals that are proposed for the project. I think when I'm doing interviews, I use the same questions for hiring firms as I use for hiring internal employees, because I think I'm really hiring these people to be part of my team. I'm not hiring the company, I'm hiring the individuals proposed by that company. For construction and trades, we will typically ask for their business terms. So what is the overhead and profit you're proposing for the job? What are your labor rates? What's a rough estimate of how much a job like this might cost based on your experience? But they're not bidding anything. They're just proposing business terms, and we're picking the best parties for the job based on their experience and the people proposed. So once those parties are on board, as I mentioned, there are multiple signatories to an IPD contract. So the most simple version would be a tri-party agreement where the owner, the GC, and the architect or the primary engineer sign this contract. There are other contracts. The project I'm working on at Parnassus in San Francisco has 12 signatories, so that's a poly-party agreement. Um, I personally prefer tri-party because there's less parties to negotiate with, and it seems easier to get the contracts done. And generally, the trades and the design engineers are okay with that structure. If you feel like you need to have more of a direct connection to the engineers and the trade partners, you can pursue a poly-party approach where you actually have more than just the three signatories. In a three-party agreement, you can still have designers and trade partners, so mechanical, electrical, plumbing, framing, and drywall. Those are kind of the minimum, in my point of view, for healthcare projects. Participate in the contract and participate in the risk reward structure. They're just not a signatory to the agreement, but the same terms and conditions can be passed down by either the GC or the architect to other parties that you want. And so the largest I know of, one of the Sutter hospitals in San Francisco, had three signatories, but it had 17 parties on the job between design and construction that were participating in the contract structure, the waiver of claims, and risk reward, profit at risk, guaranteed cost, share in the savings. So there are multiple different IPD contracts. So the terminology is a little bit different, but in general, they all have a senior management team or an executive team that is made up of the signatories of the contract. And then below them, they have a project management team. This is the most important team on the project. These are a member from each of the signatories in most cases, the owner, architect, and contractor at a minimum. And in this contract, they are responsible for delivering the project consistent with the validation document. They are empowered to interpret the document. They are empowered to commit their companies. And the only thing that the SMT does is approve changes to the scope or the contract value and replace members of the PMT. Other than that, the PMT is fully empowered to run the job. And then below the PMT, the PITS is the contract we have. This is often called cluster groups. I've seen them called SWIFTs or many different names, but these are functional groups like mechanical, electrical, and plumbing, or a core and shell team, or a substructure team. They're functional groups of designers and builders that are given a specific scope and a specific budget and usually a target, and they go and work on that. And then there's also what I'll call qualitative pits. There are often an innovation pit or a prefab pit. So they're not managing a specific scope of work and a budget, but they have a specific umbrella of concepts that they're tasked with promoting on the project. They report up to the PMT, and that's how the project is managed. So in the validation phase, this is the McLeamy curve. I think you've probably seen this before. So this represents the level of effort when it is implied in the project. And so the typical effort on most projects where everybody's really working and grinding on the job happens during the construction document, tendering, and I'd say it actually happens in the construction phase with submittals and RFIs and completion of the design. IPD is looking to pull that earlier where it's less costly to make changes in schematic design. It's much more costly to make those changes in the middle of construction when you're ripping something out, for example, and replacing it versus just changing lines on paper. So let's move the effort and really get things right when we're still designing and not do it during construction. Validation seeks to help the owner answer this question and get the designers and builders in line. Can we deliver the proposed program in quality within the schedule and budget that the team can deliver that's supported by the business case? So you put program, quality, schedule, and budget together, and you need to be able to generate enough revenue from that project to pay for the project. The validation, I would say, is often misunderstood, but when done well, sets the project completely up for success. This lays out the full roadmap of where you're trying to get to, and it gets everybody on the same page. Within that validation, there is different contracts call it different things, but they're all pretty consistent in that there's a cost of work with overhead in it for all the designers and builders. There's a contingency that's to protect the profit, and then it's either called profit pool, risk reward pool, or incentive compensation layer. But this is essentially the profit of the designers and builders that they agree to put at risk. And then if the contingency is some of it saved or even cost of work savings, there's a shared savings to the team. So with the validation being set up, target value design or target value delivery, the goal is once we've established a budget and a program, we need to finish the design consistent with that budget. We don't need to just go off and design and then do these batches and hand them over to the builders, and then the builders just estimate what's on the drawings. When this functions well, the estimator is one of the core drivers of design in the early phases of the project. So when they put a budget together, they have a detailed budget that's far more detailed than the design is at that point in time. And then that budget information is given to the design team as an input to the design, not as an output of the design. So I'll say it again. You take a detailed estimate and you give that to the design team, and that becomes the parameters that they have to work within. We have this much metal panel on the job. We have this much soffits that you can use. So the designers then need to be creative and design within the parameters of the budget. If they don't, and which often happens, more and more things get added to the design, the budget creeps up. Most models, the owner just provides a change order for that. In the IPD model, once the target is set, those overages from scope creep in design, unless they're driven by the owner, actually come out of the collective profit of the team. So designing to the budget is paramount for everybody to be successful on the project. So what it means in practice is throughout the design process, you're going from schematic design, basic lines on paper, basic rooms, to a permitted set of shop drawings. You're going from cost per square foot on things, and you're moving to takeoffs and vendor quotes. And so as you navigate through that process, you need to keep your eye on the prize that the design is evolving consistent with the budget, and the design is not increasing the budget. In practice, you do that through cluster groups or pits and heavy use on building information modeling and coordination. So the process, how this works is originally you set the budget, you have your teams, you finish a validation document. This is where the owner says, I have $1 billion to spend and I need this many patient rooms and this many ORs out of it. The team does a validation study and says, we can give you this building with this amount of rooms, this amount of operating rooms. We can deliver it for this much money. Here's the quality. The owner will take that validation document, that program, and that business plan and get funding and come back to the team and say, okay, I've gotten funding approved. The team will take that budget and break it up into individual buckets, assign pits or clusters to manage those buckets. And then to make it work well, each pit or cluster needs to have a champion, somebody that owns overall facilitation and action tracking accountability for that group, and then reports it up to the PMT or the core team. So this is a very iterative process. You have the design advances, the budget is updated, risks and opportunities are identified, the team studies those, they look at the cost and the trade-offs between them, decisions are made, design advances further. And so this cycle goes, and then it looks simple here. It's an easy concept, but not, or it's simple concept, not easy to deliver. If you do that well, then you finish design, you finish construction, you're able to deliver the project on budget. An example of what this looks like. So this is from an actual project, an MEP fire sprinkler low voltage pit and a core and shell pit. So they had their initial budget, which was delivered from the validation. There was a target in green set for each of these pits. And then on a monthly basis, the pits updated their budget. So they're tracking a detailed risk and opportunity log, and they're taking the summary of those. I'd say a lot of projects now are using Join as a really good tool to track these dashboards. And so you can see here, one of the pits, the core and shell, exceeded their target. The MEP did not hit their target, but they were well below their initial budget. And then what matters for the team is collectively the overall project is under budget. So I've mentioned a couple times, how do you align the team? So a typical IPD deal has a either an allowable cost or an estimated maximum price. There is a line I've represented in blue that if the cost is below that line, so there's shared savings. That can be done in multiple different ways, but the team will get their full profit if they can deliver the job below that at-risk threshold. That was a Sutter term. Other things call it the target cost, but there is a place where if the cost is below that, the team gets all their profit and some shared savings. And if the cost goes above that blue line, then the overages get paid by reducing the team's profit. If the cost were to go completely through the profit, then the owner guarantees the cost of the job. So everybody gets their cost and overhead, but they will not make a profit on the project. The trade-off there is a company will never go bankrupt. They'll never end up building the building for free. I shouldn't say they could go bankrupt, but it won't be because of this deal. It will be because of other things they did. But no party that agrees to put their profit at risk will ever deliver the project for less than it actually costs them, plus their overhead to deliver it. The owner agrees to pay the cost because in most cases, the owner never gets a building for less than it costs to build it. So whether you have a lump sum or a GMP, it's always going to get increased to represent what it costs to build the building. And if you have a lawsuit, in most cases, you're going to end up paying what it costs to build the building. So from the Sutter board perspective and at UCSF, we acknowledge that we're really not taking any different risk than we typically have, but the team is much more aligned than they are in other models to work together and deliver successfully. This is just an example of two different risk pools. So these are two similar jobs. The pie charts represent the total profit as a percentage of the total profit pool that each firm had. Um, if the project starts to go over budget, this pie gets smaller, regardless of who goes over budget. Everybody proportionately gets less profit. If there's share savings, the pie gets bigger and each party gets their proportional share of that. So this is no fault in the sense that if one company goes over budget, that overage is shared by all companies. So in practice, people work together to solve problems instead of finger pointing and trying to isolate them. And I have a good example a little bit later of how that happens. So again, simple, but not easy to put together. But once you've done this, you've got everybody aligned on the budget, scope, schedule, you sign the contract, and you go into delivering the project. So I want to provide an example of, in practice, how issues get resolved. This is one of my favorite. You've probably seen this before. So the issue for all owners is, sure, you can bid the job, you get a lump sum, you can negotiate a guaranteed maximum price. A lot of people think that a guaranteed maximum price actually means that's the most you'll end up paying. But there are lots of change orders. There are lots of ways for design and construction teams to follow the contract and still increase the guaranteed maximum price. So, how do change orders get handled within an IPD framework? So this is a medical office building delivered in Sunnyvale for Palo Alto Medical Foundation. It's an outpatient clinic. It's built on 2 floors of underground parking, so pretty big concrete job underneath that this sits on. And what I'm going to focus on is this roof structure where you have an 8 foot cantilever out from the edge of deck where you have metal paneling underneath, and then you have roof trusses underneath. So it's a zinc sheet metal mansard roof, these overlapping panels. And we had a problem in construction with this 8 foot cantilever. So as we're installing, we had a trade partner with guaranteed cost who took on this scope, but they bid the trusses to a lump sum design build truss fabricator. So these are what those trusses look like as they're being installed. These are all individual trusses. The structural engineer provided loading criteria. The design builder then designed trusses to that loading criteria. There's over 1,000 of them on the project, and a lot of them are the same, but then there's a fair of uniques. And then once these are installed, you can see they go out to the edge of deck and then they actually drop down, and then the cantilever goes out below the edge of deck. And then you had to come in and install a bunch of cribbing between the individual trusses. And then, thank you, California, we had drywall in there, and then we had to have 2 rows of fire sprinklers, even though there's nothing in there that could burn. But it's very well protected. There's no storage in there or anything. So fairly complicated. The challenge is as we're building this and the thin brick contractor is coming up and they're starting to install these metal panels on the underside of the truss, this is supposed to be a 90-degree angle, but it actually was less than 90 degrees. It was 86 or 87 degrees. So what that means is that these trusses are dropping a little bit, and they're not supposed to be. To make it matters worse, we hadn't even fully loaded. So this corner was failing, but we hadn't put the rest of the waterproofing and the zinc panels hadn't got here. The gutter wasn't fully installed, and it was still failing. Now, I want you to think for a second on your projects, how would an issue like this get resolved? Just give you a couple of seconds. My experience, any other job, this would have been a major fight. The job would have stopped while we started finger pointing. So this was the truss supplier's response. We said, your trusses are failing. And their response was, we can't explain the deflections that are reportedly observed. So they don't even agree that it's happening. It's possible such things could have resulted from blah, 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 but we don't have any evidence. So essentially, they said, yeah, we're not even agreeing that there's a problem. So in any other agreement, I would have had to be really involved. But in an IPD agreement, my one question to the team was, did I change the scope? And the answer very quickly was no. This has always been part of the validation scope. We owe you the building. It needs to function. So I was essentially out of the equation, and the design and construction team banded together to figure out how to solve the issue. And it was actually pretty complicated to fix. So here you can see this top chord of the truss is sagging. That's what it says on this. The engineers were arguing about whether it was sagging, twisting, rolling, deflecting. I didn't know the difference between all those terms. But to fix it, we had to basically screw a new stud along this top chord. But in order to do that, you had to straighten it out first. So we had to put scaffolding around the entire building and jack the trusses up. And then someone had to climb in, for all 1,000 trusses and screw a new stud on. And then once that was done, they could lower the truss. So think about what cost impact and what schedule impact that would have in a lump sum or a CM at risk job. Now, on this job with an IPD contract, it cost 250,000 to fix that between the designers and the builders. The way those costs got allocated, 40,000 was recovered from the design build trust contractors. So um, while they did not pay for the whole thing because it was gray, the trusses failed, but it turned out the engineers' design loads were incorrect, and the actual building was heavier than their design loads or the roof structure, but that the trusses actually failed before they even got to the design load. So it was a little bit gray about who actually messed up. So there was a settlement with the truss contractors. Some of their retention was held, but not all of it. So they got paid their costs plus most of their retention. The design team and the construction team ended up spending 210,000 of contingency on the issue. So if that contingency wouldn't have been spent, they would have gotten 70,000 as a bonus. I would have got 140,000 of it back. So essentially, this $250,000 issue cost me $140,000 of contingency that I might not have otherwise spent. But the big thing was that we lost no time. So within a week or two, they figured out what the fix was. The trade contractor allocated people. They got the scaffolding out there. They went and resolved the issue. And then we kind of trued up the numbers after the fix was complete. I like this example because I think it's a good example of complicated issues that happen in the field. And traditional contracts, we'd be fighting about this for 6 months or a year. And in this contract, we were working on the fix within 2 weeks. So there are role changes when you change the structure and you build a collaborative team. This is a lot more of the how the lean operating system works, but we go from this top-down CPM scheduling, detailed schedules issued by the general contractor, and we shift to collaborative planning. The lower right is a milestone schedule for a $170 million project with a new hospital and 12 renovations in the existing hospital. And this was the contract schedule, and that shows all the planning, permitting, and construction work. And then a lot of this, I'm sure many of you are involved in pull planning, implementation of the last planner system. The point here is we're planning the work with the people who are actually doing the work. We're also making a shift. We're not just designing for intent where we have 2D drawings that show what we're thinking, but we're actually designing and modeling and coordinating so that we can fabricate from our design documents and we can install this in the field. So this is a picture of two tradesmen in the field actually pulling up the model and confirming that they're building what's in the model. I like this slide. So we're going from the left-hand side where we're yelling at each other and we're pointing fingers about whose fault it is and who has to fix it. And we're moving towards a collaborative risk and opportunity tracker where the team is collectively sitting down like this trust example and saying, okay, what's the issue? What's the most cost-effective way to fix it? Who's in the best position to implement the fix? Now go ahead and implement the fix and we'll track the cost. So much more collaborative. Doesn't mean we still don't have problems, but the way we resolve them is much more collaborative. And then, as I mentioned, we focus on the culture. I like this is from a project in Roseville, and we invested heavily every month. We had team building meetings. We brought in lunch. We alternated who facilitated the meeting. We went through all the trade partners and designers. We had project engineers facilitating the meeting. And then the right side, we actually once a month for probably about a year, we had a poker tournament. Everybody would go home. they'd have dinner, and they'd come back, and we'd have a poker tournament that had representatives from the owner, the designers, the builders. So all of this was to build that one project spirit, build the collaborative team. And so when you invest in relationships, you get the payoff when hard things happen. And so you've already invested in trust, you've invested in team building. So when things go wrong, you've built credit, and then you can draw on that credit to resolve those issues. And I'll emphasize again, when you run a project like this, people are sad when it finishes because it can be incredibly rewarding to participate in a high functioning team. So, coming to a close here. So, we do, as I mentioned, have IPD on a public project in San Francisco. So, right now, we're under construction on the Helen Diller Hospital, previously called the New Hospital at Parnassus Heights. This is a roughly 940,000 square foot expansion. It is a massively complex building. We have 30-foot steel cantilevers. Some of the drilled piers go down up to 200 feet on the front of the site. Down on this side, they go down 200 feet. On this side, they go down 20 feet. So we're bedrock is dropping very steeply on this hill. You can see all of the cantilevers. We have ceramic tile on the lower levels, which apparently is incredibly heavy. So you need to design massive steel to support it. We have a lot of wood paneling. We have metal paneling and these projections, which are going to be made out of trusses that are supported off of the curtain wall system. I thought they were part of the decks originally. So we have a 12-party IPD team working on this project. It's about a $3 billion design and construction project. And I'm really looking forward to it's not easy, but to having a good case study of successfully delivering a hospital in a public environment at the end of this job. We're still early, so these are pictures from last week of the site. Uh, Pretty massive excavation. We are right up next to an operating hospital where we're doing lung transplants and brain surgery. So our number one focus is to keep the existing hospital fully functional and operational while we're doing pretty massive construction next to it. You'll also see we had to build a bridge out into the middle of the site so that we can get the crane and the concrete pumps close enough to pour the footings. The back side of the site here is fire access and the loading dock for the hospital. So only in very limited instances can we close this road back here. So we really only have access from one street, and it's very narrow. There's almost no laydown area. So very complicated project. Just to compare progressive design build versus integrated project delivery on change orders. So there's another project, hospital going on in the UC system that's at a similar phase. We have had about 110 change orders to get to this point on the project. We've also done $200 million of make ready work. Most of those change orders are for unforeseen conditions and owner directed changes. So almost no changes related to actual design and construction coordination. Whereas a progressive design build project at a similar phase has experienced over 1,000 contract change orders. So there's another just quantitative. We can manage this project with a much smaller owner team than we would need. So we have about 20 people on our team. If we were doing this with progressive design build, we would probably need 2 to 3 times as many people on the owner team to handle the paperwork related to something this complex. So I want to just finish with some final thoughts. So hopefully I've persuaded you that there's at least something worth looking at in integrated project delivery. When projects are highly ambitious, they're very technical, they need creative solutions, they have high sustainability goals. So our buildings have a LEED Gold target, they're all electric. We have carbon reduction goals. We have a tight material list of things that we won't use because of sustainability. So when you have all this complexity, this model works. If there's a lot of value to the budget, if schedule is really important, then this is a good model to look at. If you're building an office building or something that's not that complex, I might not recommend IPD because you'll IPD works when you have an upfront investment in the team. And if the building is not very complex, you won't get a return on that investment. So if you go through this list and a lot of the boxes that you're checking are high, then I would consider IPD. If you can't do that, progressive design build is better than nothing. And then CM at risk with heavy pre-con is what a lot of public entities are going to have to use. I would still recommend doing a lot of things that I covered, even if you have to use that contract. So I'd still do a validation process. I would use a lean operating system and I would invest in culture. You just won't have the alignment of the contract incentives. And so if I've piqued your interest, um, outside of my day job, I edit a website to try to help owners and teams with the implementation of integrated project delivery. It's leanipd.com. We have a 2.5 hour course that is narrated by some true experts in the industry, including Howard Ashcraft, who I think has written more IPD agreements as an attorney than anyone else in the world. And so, as part of the Lean Construction blog, we're offering 50% off of this course. You can take a picture of the screenshot. If you have any questions for me, please feel free to reach out to me. I'll have my email on the next slide. But there's a ton of additional information at leanipd.com. And I also have a YouTube channel, youtube.com/leanipd, which has a bunch of how-to videos and things that a lot of people say is helpful for them in their journey. So with that, I'll finish. My email is here. The website is here in the lower left-hand corner. I'd like to thank Dwan and the Lean Construction blog for the opportunity to share.